Hello, my name is Rhys Jenkins. I'm the product manager at Servomex for process photometric analyzers.
I am Stephen Firth. I'm the Global Business Development Manager for Servomex. And today we're going to talk about combustion control and the trend for more and more safety coming into what is a traditional combustion and efficiency market. Rhys, can you tell us a little bit about traditionally how combustion control has been used in the process industry?
Traditionally, combustion control would be a zirconia oxygen analyzer and often a polyester-based CO measurement. And you were looking at reducing the CO levels and the oxygen levels so that you were burning the least amount of fuel. Today, we are seeing a move towards tunable diode laser analyzers for measuring CO, but also CO CH4. And this is for better safety.
And why has the movement been to the new technology?
In recent years, we've seen an increase in the requirement for methane in the analysis, and especially for safety systems. And this is led by the prevention of fire, so fire prevention and explosion prevention.
Why the move to safety? I mean, we've been measuring combustion efficiency for 50 years or so.
In the last 10, 15 years, the decrease in emissions, especially the NOx emissions, has meant the introduction of low NOx burners. Low NOx burners in themselves are fantastic at reducing the levels of NOx emissions, but because they run a cooler, larger flame, the flame itself is inherently less stable. I think our customer base is finding that the flame instability is leading to the requirement of better flame out detection.
And so why does the laser lend itself to this measurement? What's its specific advantages?
The laser-based measurement is a cross-stack measurement as opposed to a point measurement. So it would pick up any flame out situation across this whole path length, as opposed to a traditional point measurement measuring just oxygen and CO. So a laser doing an average measurement across the process is better for protecting these banks of burners as they become unstable and maybe burn out. Coupled with that, the laser can offer both CO and methane in the same product, the same laser in fact. This allows you to do more analysis with one product, and it's very specific to CO and methane, which gives you a better idea of what is going on inside your furnace.
So what's it about the TDL, the laser, that gives us this inherently better measurement than the traditional technologies?
Well, a TDL analyzer, because it is essentially a light-based measurement, an infrared measurement, gives you almost instantaneous response to any changes in the process. There's no extraction, there's no having to pull a sample, even a meter or 2 meters. It is response as fast as the electronics can handle it.
So we're really talking about a 2 or 3 second response time.
2 or 3 second response time, which is vital when you're talking about maybe the difference between 5 or 10 seconds being the fact that the boiler might go into an unsafe condition. The faster you can respond to the event, the more time you give the operator to take corrective action.
And what are the 2 key conditions that the customers are actually looking for on these boilers?
Boilers, when they're running in steady state, are generally very safe and can be trimmed and controlled using the oxygen and the CO. But there's 2 states. The first one is startup. Doesn't happen very often. There are strict rules on site dictating what goes on, but you can't get away from the fact that as the furnace starts up, bits of it are at different temperatures than each other. Therefore, it's being monitored during that condition for flame out conditions, high CO conditions, reducing conditions, so that they can take corrective action. Also, with good analysis, you can potentially speed up your startup process, more aware of what's going on inside the furnace. The second condition is when something changes. The ambient conditions change, the fuel changes, or the pressure regulation to the low NOx burners changes. Because we discussed their flame stability is less in the low NOx burners, these things can have an effect of snubbing out the flame, or at least changing the flame profile so it becomes heavily fuel rich. In that case, you can have a pocket of methane existing on a bank of 2 or 3 burners inside a working process. These point measurements wouldn't detect it, and you could potentially have a flood of methane coming up through the process. Whereas when you have a laser-based product, it detects across the whole length of the process, therefore it would detect that bank of burners going out and allow the operator to take corrective action. And normally they would look at 3 points: an early warning, a manual intervention point, and if it went suddenly very high very quickly, you'd have an automatic shutdown point. So it's vital that we have a measurement that is robust and reliable and repeatable to do this type of analysis.
Because obviously they want a safe system, they want a safe analysis. How does this relate to the rest of the control system?
The laser in itself is only part of the overall control system. But any control system does not want to see either false highs or false lows. The last thing you want is there being an unsafe condition and the laser doesn't monitor it. The other thing you don't want is the laser falsely giving false highs, shutting the process down at a high cost.
So you've told us a little bit about the TDL, but how does this relate to the safety of the complete system?
An overall system is on the plant is designed to a particular safety instrumentated system level, which is abbreviated to an SIS. The laser is only one component of that, and we will be looking at SIL 2 levels for our particular laser, which is a high level of reliability and robustness, and is all about the confidence of the measurement being correct as reported. In systems where a high degree of safety is required, often you would have 2 lasers installed with the same measurement. That gives you redundancy in your measurement, and that's normally described as a SIL 3 level system in this case. It is done from the hazard analysis based on the plant, and will be introduced around with flame out detection that they may have, whether or not the pilot's on a separate line, and all other factors come into it. But the laser is a vital part of that because it is generally the last factor in the protection cycle. It detects the breakthrough of the hydrocarbon. All other elements in that system have been looking at preventing the breakthrough of the hydrocarbon.
For further information on Servomex TDL lasers and how they can assist with the safe running of combustion processes, please contact your local business centre or visit servomex.com.